The 4-year Eta Cooler development period demonstrates our effort to provide the industry with a well-engineered design. Strictly modular is one major principle of the new Eta Cooler. The total cooler is built out of basic modules for a capacity range of up to 15,000 tons per day. Let's have a look at the design of the modules. The front end of the cooler is equipped with the static inlet, the high-efficiency HE module. It achieves an optimal clinker distribution over the width as well as the quick quenching of the clinker. The inclined, totally flat HE module extends from the kiln drop point to the transport lanes. It is aerated via independent zones. The slot plates are fastened by a single bolt. The transition from the static area to the movable lanes is accomplished by the first Eta Cooler module with cross-sealing under the HE module. The moving, walking lanes require a unique seal design. The very special cross-seal inside and between each lane has been designed to ensure that the cooler is totally riddling-free. It uses a transport system that is unique to any of the present coolers, the walking floor system. The Eta Cooler consists of parallel transport lanes which are moved together in the direction of the clinker transport and retracted individually or in groups. The individual cooler length and width for different clinker capacities will be built out of just two main module lengths. The width is variable by the number of lanes. Depending on the required throughput capacity, a corresponding number of parallel transport lanes are installed side by side, each supported on independent heavy-duty rollers. Independent lane movement, parallel, individually driven, air-rated lanes. The slots for the air supply are integrated in the transport lane bottom by utilizing the Malden grate plate principle. The cooling air can penetrate over the entire bottom without any large dead areas. The Eta Cooler has one or two hydraulic cylinder drive modules, depending on the capacity. Each lane drive is connected to one hydraulic unit, the power pack. The hydraulic cylinders with integrated continuous measuring system dedicated to each transport lane enable an adjustable long lane stroke. The speed of each lane can also be adjusted to the requirements. The last module of the cooler is the transition to the clinker crusher. This module is built out of the two standard units of different lengths. The active width of the crusher corresponds to the width of the Eta Cooler. During the forward stroke, the lanes convey the clinker to the grizzly chute for screening the fine pieces and guiding the oversize directly to the crusher. The first unit is leaving the workshop in time on its way to the Ziegenthal cement plant. The plant is located in the north of Switzerland near the French and German border. The capacity of the kiln line is approximately 2,000 tons per day. Another major objective of the new concept is the time-saving method of installation. This is helped by simple foundations and less civil engineering work. The first Eta Cooler size 645 replaces an old reciprocating grate cooler. The modules are lifted, one after the other, onto the burner platform lowered down by the indoor crane onto the ground floor. The opening in the burner platform was only slightly larger than the modules, and a very precise job was required. Thanks to excellent teamwork, the modules were brought safely into the cooler building without any problem in an extraordinarily short time. On the cooler floor level, Each module had to be moved on rollers exactly into its final position. An amazingly precise and professional job, and the time saved compared to an ordinary assembly was tremendous. The same procedure 6 times, and after only a few hours, all Eta Cooler modules have been joined together again. Now the hydraulic piping and the electrical installation, as well as the refractory work, can start. A major part of the refractory has been reused. Here we can see the HE module with special horseshoe castable design and integrated air cannon nozzles. Finally, the whole lane bottom is filled with clinker for heat protection. After all the years of development, all the hard work, everyone looked forward to this great moment. Clinker cooling has evolved. The next generation of clinker cooler is born. The new Eta Cooler fits perfectly into the existing cooler building. The cooling fans are located in the basement on both sides. The hydraulic cylinders are connected directly to the power pack, which is placed on the burner platform. The cooler upper part was reconditioned and reused. The upper sidewall gives a view into the cooler through observation holes. The view into the cooler shows the unique movement of the clinker. For a clearer idea, here are some pictures of the test unit in the Claudius Peters Technical Centre. Forward stroke, 100% of the clinker moves forward. Backward stroke, only 20 to 25% is carried back. The higher transportability of the Eta Cooler is not the only advantage. Even more valuable is the independent lane movement. The Eta Cooler transport system actively influences the clinker conveying and distribution. For the first time in clinker cooler history, this virtually eliminates such problems as Red River.
In the 60s, the satellite cooler became popular due to its simple design. With the introduction of the pre-calciner, they became old-fashioned. Satellite coolers are no match for a modern-day Eta Cooler with its low maintenance cost and the excellent heat recuperation. The good experience with the Eta Cooler in Aix-les-Pins, where Claudius Peters replaced a satellite cooler in only 36 days, led Holcim to their decision to carry out the same upgrade for Untervaz. The Eta Cooler had to fit between the kiln pier and the clinker conveyor. This gave a special challenge to the cooler design. Claudius Peters offered a 5-lane cooler with an internal width of 3 meters. During the kiln stop of 2011, the foundations were prepared. In the first weeks of February 2012, the kiln hood was welded together in preparation for the major kiln stop, the replacement of the satellite cooler with a state-of-the-art Eta Cooler. February 13th. The satellite cooler is stopped for the final time. Now everything has to be planned in detail to ensure a quick turnaround, as every hour the kiln is not producing costs money. The robust modules were completely pre-erected under workshop conditions. In just a few hours, the modules are placed on the foundation. The modules are lifted with the in-house crane on heavy-duty rollers and can be easily moved. Then the final positioning takes place and the HE module aeration box is placed. The modules are installed in only one shift. The kiln hood, complete with refractory, is lifted in 3 parts to its final position. During the cold commissioning, the movement of the aerated lanes is tested. The clinker on the lane that moves backward is held by the sidewall and the lanes beside it. This ensures superb transport efficiency. At the end of the cooler, the clinker is pushed onto the roller crusher. The lanes are positioned on heavy-duty rollers. They are driven by hydraulic cylinders. Claudius Peters gives a 5-year guarantee on lanes and rollers. The lanes are filled with gravel. This protects the air inlet mushrooms from heat and wear. Then finally, after all the hard work, the kiln line is taken in operation and clinker is produced.